Hello everybody. In this video I want to talk to you a little bit about osmotic pressure. And osmotic pressure is a colligative property, which means that it's a property that solutions have that do not depend on what the identity of the solvent or the solutes are, but only on the concentration of the solutes that are present in solution. And basically, the way that this works is that when two solutions are separated by a membrane that only allows the solvent to permeate, so our solvent is smaller than our solutes, and it can go through this semi-permeable membrane, okay? And the two solutions have different concentrations, meaning there's different concentrations of solute in one side than on the other. Solvent will flow from the less concentrated, the hypotonic side, to the more concentrated hypertonic side. So what's going to happen is these solute molecules here are going to continue to move through this semi-permeable membrane until there's a similar ratio of solute and solvent on both sides of the membrane. The pressure driving this is called osmotic pressure. So there's an actual pressure that's formed because of this difference in concentration, and that is due to diffusion. And we talked about that before. There's a higher concentration over here, and it wants to flow and even things out on both sides. And there's a pushing, driving force through there, which is usually symbolized by a capital letter pi. So this diffusion across the membrane will continue while there is sufficient pressure to push the solvent through, okay? At some point, because the solvent does have to squeeze past this membrane, this pressure will no longer be high enough to push a solvent through. And that's going to usually be pretty close to the point at which there's an even number of solvent and solute molecules over here as there is over here. You guys have probably heard before about something called reverse osmosis filters. You see these like under kitchen sinks and stuff. I have one under my kitchen sink, and it filters the water for you in a pretty efficient manner. And basically what happens is you start off with two bits of water usually, but it could be some other solution on both sides that have the same concentration initially. And then you start pushing on one side, pushing it through this semi-permeable membrane, and you wind up diluting this side, adding more water molecules to it and having less solutes that would be undesirable in your water on this side, and concentrating down the solutes on the other side. And this is going to continue until the osmotic pressure on this side is equal to the pressure that you've applied on that side. So reverse osmosis works by placing the same solution with the same concentration, isotonic, on both sides of the membrane. Then we're going to apply pressure to one side while solvent is transferred to the other side. One side becomes more concentrated while the other is diluted, and this continues until the applied pressure equals the osmotic pressure. One other little interesting fact that you guys are going to need for your homework has to do with the idea of this tonicity being hypertonic or hypotonic and blood cells. So your blood has a concentration of sodium chloride salt that's right around 0.9%. If you add a blood cell, which is also has an inside that's about 0.9% NaCl, into a solution that has less than that amount of salt in it, it's in a hypotonic solution. What happens is there's osmotic pressure across this membrane that goes into the cell, and the cell starts to swell and fill up with water. This is called hemolysis. So lysis is a process of killing a cell. Hemo has to do with blood. And the reason is this often causes the blood cell to die. What it's going to happen is it's going to keep filling with water until it's big, 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 like a stretched water balloon, and then it's going to rupture and the insides are going to come out, and it would likely kill it. On the opposite side, if you put it into a solution that's much higher in NaCl, you have a hypertonic solution now. You're going to start to draw water out of the cell, and they start to shrivel up. This is a process called crenation. The cells are a little bit better able to handle this without dying, but it can damage them quite a bit and often will wind up killing them. But when you do have a solution that you add, like say the saline solution that you use, that you drip into people's veins to like keep their blood pressure up and stuff and replace their fluids, is right around 0.9%. Well, then you're isotonic with the cell, and you could get a nice happy cell with a little smiley face on them.